Welcome to the Works Plus TechTalk Podcast. Today we're going to be joined by a very special guest, Peter Killeen from Concrete Methods. Today's subject is going to be, is all concrete equal or isn't it? Some of the things that we're going to be covering is commercial concrete versus residential concrete. What are the main differences? We're going to talk about cracking in concrete. And finally, we're also going to cover off on the all too popular additives that come up in conversation for concrete polishers, those being fly ash, slag, and manufactured sands. I'm really looking forward to this one. Let's get into it. Peter, thank you very much for joining us in the Works Plus Tech Talk podcast today. Peter Killeen is joining us today from Concrete Methods. Peter, how do you end up being here?
Well, I'll go back in history then. I completed a Bachelor of Building at RMIT in 1988, and I worked for in the commercial sector for 10 years, and then I ran a subcontracting business in the industrial sector. And so my experience now is all about building warehouse floors, how to make them flat, how to make them level, and how to make them durable, and not have problems with joints and the like. So I got involved with doing base slabs for polishing or for exposed aggregate finishes and trying to get the base slab better. And that's how I end up here talking to you about how to make concrete slabs better. So I think that's probably enough of my background. Uh-huh. Yeah. I've been around this industry for a long time. Yeah, you can tell by the grey.
And you're only, your mid-30s?
Yeah, something like that. Yeah.
1988, do the maths. We met, probably about 4 or 5 years ago?
Yes.
In a concrete gone wrong investigation?
Yes.
And so I met you at that time and it was like, oh, far out. I finally met someone who actually knows a bit about concrete. And so you're my go-to guy whenever I'm stumped on something. Yep. And so you've been a wealth of information for the last 5 years for us. Yep. And even a lot of the guys who listen to Tech Talk already would have already benefited from the information that's come from yep. your experience as well.
Yep.
So yeah, I mean, you make it all sound really, really polished and clinical there. But it's not really that simple. And I think the way, even when you present yourself, you make you sound like you don't have anywhere near the knowledge that you've got.
It is a very complex subject. All of these subjects with concrete are very complex.
Yeah.
But so it's easier to just have a global view and say, do it like this, and you can say that in a few sentences, but the detail usually takes many pages or chapters, and that's hard to get into. Yeah. So I just tend to wait until the circumstances arise and try to simplify the answer as best I can. So my objective all the time is to make it simple. If it is simple, quality tends to get better by itself.
Yeah.
And you don't have to keep trying to teach new people how to do stuff. Just make it easy and clear. So that's what my mojo really is. My business partner, Robert, he's very good at mixed design review, and he also tries to make it simple and tries to make sure the mixed design is suitable for the element that's being constructed.
Yeah.
And then the methodology of how it's going to be constructed. So we like to marry the concrete and the methodology together to get that right outcome.
Yeah.
And if we understand the defects, the things that people don't like, then it's possible to create a process that engineers them out of the discussion, which is a lot of what we'd originally done with the Coles work, and before that with Bunnings, in trying to get particularly edges and to get them better. And now that process is what drives me to coach other concreters on how to do a better job.
Yeah, right. Okay. You make it sound pretty simple. I'm surprised you're still in business. I mean, we had a bit of a discussion last week when I actually called you up and said, hey, Peter, do you want to be part of this? And you said, well, what would we talk about? And I had just like 2 points, and I think we talked for about, close to an hour just as a, hey, what should we talk about? Just these 2 things. And then that really just emphasized how many moving parts that you're dealing with on every single project. Not one project is the same, from the materials, from the suppliers, from the skills, from the environment. There's so many things at play here.
Yep.
And as you mentioned before, it's only the foundation and so hence we have such a high level of competency and training in our country for all concreters.
Yeah. The concrete training is not very good because concreters learn on the job from someone who learned on the job from someone who learned on the job. So we've actually got guys out there who are working in a manner that people were working 100 years ago. And there's a lot has changed, and the outcomes are a whole lot different. And we've gone from doing 6 metre square slabs in warehouses to doing 1,000 square metre slabs, and we haven't engaged any more labour on each one of those slab pours. So what's changed? Equipment's changed. The methodology of placing concrete's changed. The speed at which they have to act and get it struck off to level, and the accuracy of that, and the vagaries of traffic that have caused the concrete supply to be difficult. So there's a lot of stuff for those guys to get their hands around, and they're engaged for usually they're engaged for their talent, not for their intelligence.
Yeah.
And so without being derogatory to those guys, they're not engaged to think. So you need to give them process that they fully understand and are able to go and do what they're good at.
And it's normally a short day for these guys, isn't it?
No.
So when you talk about putting a process in place and that sort of stuff, it really needs to be simple, because you're going to start off fresh, but by the time that you're putting the finish on that, you're pretty much spent. Yeah.
So if a job has got, 20 truckloads of concrete, 30 truckloads of concrete in it, then those truckloads of concrete are not all going to behave the same.
No.
And they're not all going to come at the same intervals. And so they have to be able to deal with all those inconsistencies that occur in that amount of supply. And during the day, the weather's changed. So the set characteristics have changed as well.
Yeah.
Now, I know a lot of your customers do house slabs which are poured in the open. So they've got very big expectations of what's going to happen to them during the day.
Yeah.
And they don't usually get blessed with a lot of priority from the concrete supply, particularly towards the end of the slab.
Yeah.
So they might be lucky to get 1 or 2 trucks in the hour, which isn't a very good way to go about your business.
And one was before school traffic.
Yes.
The other one came in peak hour.
Yeah.
And that changes things a bit.
Yeah. And so you've got all of these different things that occur, and there might be an accident on the road, and suddenly there's a big delay on that. And now the concrete's hot when it gets to you, it's lost slump. So they add some water to it. Now that concrete will go off even faster. And the problem for your customers in then trying to grind or to exposure or grind to polish is that you've got what we call a cold joint. And you've got this huge variation in texture, in colour, in proximity of aggregates to each other. And there's a whole lot of things that are wrong across those cold joints.
And none of this is even documented that this happened on the day.
No.
So when the concrete polisher turns up, or the builder is he's trying to work out what's the best direction for what we've got here, nothing's recorded. We're kind of going to discover this later on when it's really too late to be putting the pieces of the puzzle together.
Correct. And I think particularly if you're doing a polished slab in-house, that there's more often there will be those sorts of defects that occur, and they're visual defects, they're not structural, but they do exist, and there's nothing that you can really do about it.
Yeah.
We all talk about beauty is only skin deep and ugly goes to the bone. Well, a cold joint goes to the bone.
Yeah, that's good. And so before you said that, commercial versus residential, commercial is really going to get the priority over residential.
Yep.
And that's really just because of the cost that's involved. And therefore you're talking about high levels of legal action when things go wrong, that sort of stuff. There's motivations for the concrete supplier to want to prioritize one over the other.
But there's also a lot more volume going into industrial, and so those customers, they just buy more.
Yes,
so
they're your best customers.
They get better priority.
Yeah.
There's no doubt. And if a warehouse floor is under construction, those guys will pour every day, and they will pour between 100 and 200 cubic metres every day.
Yeah.
And so that becomes reliable volume that gets booked in with the concrete supplier, and the concrete supplier will service those guys. And those guys scream harder when it's wrong.
Yeah, absolutely.
And unfortunately, the domestic concreter, he's if he gets 4 trucks an hour, he thinks he's pretty good.
Yeah.
And the balance load is usually problematic. Now, those guys could solve that problem if they were prepared to waste a cubic metre of concrete and over-order.
Yeah, right.
But they don't. And so they end up suffering delay, and they might not get their last load until after lunch.
Yeah.
Where they've probably started at 6 or 7 in the morning. So you can imagine the amount of cold joint effects that they get. Another problem with house slab is it's got lots of beams. 2/3 of the concrete volume goes into the beams. And so you spend a lot of your concrete filling your beams, not a lot doing the slab.
Sure, yeah.
And so you might have filled the beams ahead, but then the little bit of the slab that's been filled, you're still waiting and waiting and waiting before you can screed it. So you're getting the cold joints at the wrong part of the slab. It's always in the top.
Yep.
Yeah. If I get a residential customer to ring me and says, well, what are we want to polish the floor, what will we do? I always recommend them to do a topping slab.
Okay, so explain what the topping slab is and why you would recommend that process.
Well, the topping slab is a more controlled element. It's only going to be 80 or 100 millimetres thick. It doesn't have any attached beams, so it's not going to get cracks in it if you've detailed it properly. And the current process of putting water pipes in the bottom of that slab in that little insulation layer means that those slabs are about 80 millimetres thick. They're pretty simple to detail, and you can pour them after the walls are up. So you can pour them when you're in an enclosed environment.
Right.
It does mean that you can't do saw cut joints because the saw cut won't go all the way to the wall, but you just use 2 angles back to back, and you can create a joint that you can put filler in later. So those slabs are a lot more reliable. You can create joints to align with re-entrant corners, so you don't get unplanned cracks on re-entrant corners. If you pour a topping slab before the joinery goes in, you will have lots of re-entrant corners. So you have to be careful about where you put joints to eliminate the re-entrant corner effect.
Yep.
But other than that, they're a lot safer. And if they don't work very well, it doesn't cost a bomb to replace part of the slab.
Sure.
Whereas a raft slab, that's one go only.
Yep.
Whatever the vagary that occurred on the day of the pour, that's what you're stuck with when you try to polish it.
Yeah. So my understanding is the main reason why you're promoting doing the topping slab once we've got walls in place, and I'm assuming that's to try and control some of the environment.
Yep.
Sure. Okay. From a grinder's perspective, hate your guts.
Okay. because the edges are hard.
Because now we're doing edges, yes.
No, I understand that.
Yep.
And another way to do it is you can pour that topping slab, literally prep for it the very next day.
Yep.
Then what it means is making sure that your set out for the frame is going to be accurate.
Yep.
And form your edges so that they're just inside where the frame goes, and the gap between the frame and the edge of the slab will be covered by the skirting.
Okay. Yeah.
So that's another way to do it. But it does mean that you're outside when you pour it, but when you do it, you're at significantly less volume of concrete than you were before. So 100 millimetres thick, 1 cubic metre will go 10 square metres.
That's right.
So a truckload goes a long way in that environment. So your whole pool might only be 3 or 4 truckloads.
Yeah, correct.
And that becomes a whole lot easier to control.
And that's probably, if we're doing this in a residential, we're probably also doing a decorative concrete. So we're looking at increased per cube rates on that as well.
Yeah.
So there's a cost saving there for us anyhow.
Yeah. Yep.
You mentioned to me the other day that residential slabs are made for cracking.
Yes. Well, they have beams in them, and they have beams in them so that the slabs don't heave when the ground moisture conditions change, and so that your doors will still open and close properly. And if they didn't have those beams, then that would be problematic with house slabs. So the beams cause restraint, and we can't stop the concrete from shrinking. So when there's a beam, the slab's going to shrink, and the beam stops it from being able to get smaller, basically from the slab getting smaller to accommodate the shrinkage. So it gets relieved through cracking in the top of the slab.
Gotcha.
All right. Now, if you put a lot more reinforcement into the top of the slab, you can control the width of the cracks. But according to the residential footing code, you don't actually have to put a lot of steel in it, and they won't keep the cracks tight. So if you polish your floor before all the shrinkage or most of the shrinkage is done, those cracks might open again.
All right. Can we talk about those? Can we talk about that shrinkage?
That shrinkage.
Yeah. What type of time frame are we talking about here?
Well, I find in the industrial sector that your joint widths don't really settle down until about 18 months after you've poured the slab.
Right.
Technically, the majority of the shrinkage has occurred in 56 days, but we do see cracking occurring after that. And I think people might they build a new house, moved in, 2 or 3 years on, they decide their floor covering's not very nice, they want to change them, and they lift up the old floor coverings and go, oh dear, what happened to our slab? And so the residential footing code has an appendix in the back to describe how big those cracks can be before you should panic.
Right.
Yeah, because it's going to crack.
Yep.
But yes, if you put a lot more reinforcement in the top, then you can keep the cracks down to barely visible.
Yeah, okay.
But it is a lot more steel.
Yeah.
Yeah.
So that would basically be on the engineer. Engineer would need to know that this residential slab is actually going to be poured with the intention of polishing it, grinding it back and polishing it, and we want to reduce cracking.
He won't. Mostly, sorry, I shouldn't use that gender. The engineer may not consider that unless there was an instruction from the builder, and the builder most likely won't consider that unless he's been caught on defects before.
Yep.
Or the customer has spoken about it. I don't want to see cracks.
Mm.
So it might be that the owner needs to be educated about what can happen and pass that story back.
Mm.
So if your polishers are engaged early, particularly with the owner, then you've got more opportunity to influence that in the design.
Mm.
Now, somebody might say, oh, it'll be right. Well, that's great. At least you've then told you so.
Yeah. Instead
of I could have told you that later. So the cost of the increased reinforcement might be $4 or $5 a square metre.
Mm-hmm.
And eventually someone will realise they should have paid for it.
Yeah, okay. So we've got all of these guidelines, provisions written in code for many other aspects of the build process.
Yeah.
This type of information, where should that sit?
Well, consultants like me make a lot of our money out of failures, compliances with codes that were not fit for the purpose.
Yeah.
So it really is about using experience and asking the right questions, because people tend to, when they can't answer the question, they realise what they don't know.
Mm-hmm.
And so you can influence the decision makers if you can ask the right questions or make a demand. I don't want any cracks.
Yeah.
I did it to the builder that built my house. I told him I didn't want any cracks in the garage. And his engineer carefully designed it not to crack. And that's occurred.
Mm-hmm.
It's cracked 12 years. So it's possible to get it. You just need to be asking for it up front.
Yeah.
Not just buying Me Too, because the code really only provides for Me Too.
Gotcha.
And your customers' customers are not buying Me Too.
That's right.
So they need to make sure they get out of that envelope that Me Too sits into and say, no, I want special, and go that way. And I guess maybe that if your customers are in a position of following that inquiry, is providing that information as early as they can.
Yep.
Hopefully before the slabs are cast.
Oh, that'd be nice.
Yeah.
But we're only ever standing there pointing the finger at each other when
I know.
when the clients moved into their dream home.
I know.
For their forever home.
And I make more money out of that.
Forever cracked home.
Forever cracked. Or, yeah. I think we've detailed a few fairly flash houses, mm-hmm. and on the slab, and every now and again we'll get to a situation where we want to put a joint here and the customer says, I don't want a joint there. So do you realise that it might have a crack here on that corner?
Mm-hmm.
Can you live with that crack or not?
Yeah.
And often they'll say, yeah, all right, I'll live with that crack. Great, you've made an informed decision, mm-hmm.
and
you're prepared to live with the crack. So what we would do then is put more steel across the re-entry corner, diagonally across the re-entry corner, and try to hold the crack tight.
Yeah.
And then when you grind and polish, hopefully your regrout is hitting the crack.
Yeah.
Yeah.
Maybe we'd like to get there 18 months afterwards, and so all the shrinking's already occurred.
Yeah. That'd be nice. Probably not going to happen.
People actually don't want to wait that long for a home to be built these days, do they? They're going to be there for how long? But they want it built in X amount of time.
That's right.
Yeah.
Yeah.
That's part and parcel of living in the society we're in today, isn't it?
Yeah. I think the development with the hydronic heating under the slabs has given a lot more opportunity to say, well, if we do hydronic, we've got to have a topping slab. Let's polish the topping slab.
Yeah.
So there's an upside to the customer for paying that extra to get a topping slab because they're getting the hydronic heating at the same time.
Yep.
So that might work. I think the hard one is where a customer has made a decision partway through the build to say, oh, let's polish the surface.
Correct, yeah. It was not set up for this from the first place.
No, and then they would realise that that's cheaper than tiles, so they want to go down that road. And I think people need to be informing them this may not look as good as your vision.
Yep.
We'll do our best, but it may not look as good as the vision that you have. And I find it difficult to get people to understand a vision using words. You can only get visions realised with an image.
The horror story.
Yeah, or a photograph of, hey, here's one we did in Torquay, here's one we did in Campbellfield, here's one we did in Mount Waverley, and let the customer realise the potential of variation that might occur of that type of slab. So photographs are really good to show people and make the record. I did show you these photos. Do you remember? I gave you copies of them.
Yep.
When you then can compare them to the outcome, it's consistent. I'm not sure what you're complaining about.
I can see that being some good advice. We tend to take photos of all the good stuff that we've done and make the images look good, and that's what they're buying into.
Yeah.
We don't tend to take a lot of photos of the failures or at least share those, but they're the types of things that you need to share to educate the customer and for them to understand the value and what you're bringing with your advice.
100%. Yeah. Yes. As a real life working sample, this is what your slab could look like. I have no control over the construction of your slab. It's already constructed. All we can do is do what we can with what we've got.
Oh, but Peter, they might not go ahead with the
I'm
project.
Sorry for that. Sometimes it's better to have missed the job
than to have to be dealing with it at the end.
Dealing with
unhappy customers.
Unhappy customers at the end. And the problem with unhappy customers, particularly social media, it's so easy to put on Facebook. Don't use these guys; they're terrible.
Yeah,
and you would have been better off not going there.
But your work was great, but the conditions didn't suit.
Yeah.
But you can't really say that anymore because now you've listened to the podcast. These are the types of questions I need to know. This is you're limiting your own risk in getting involved in this project.
Correct.
And because you know now, you can do that.
Yeah.
So that's actually a win-win for everyone here.
Yeah.
The client and the contractor.
Yeah. I use this strategy all the time of, I don't think I can do this job.
Yeah.
And now the customer wants to talk me into doing the job. So, and I think if you've shown them bad jobs or jobs you're not really happy with, is that it actually improves your credibility.
I believe so too.
And so you show the full spectrum. Now, this is a slab that we did that the concrete has done an awesome job, and look how good it is. But this one over here, the slab wasn't so good. It was a bit soft on the top, had a few cracks in it, and this was what we managed to achieve.
Yeah.
We were pretty happy with the outcome, but it's not as good as this one because the base we had to work with was not as good.
Yep.
And then you showed the full range, and I think that adds to the credibility and make the wife happy that she's going to get the best that she can get for what she's got, rather than having that perception of you did a bad job. And when I've worked on housing work, it is usually the wife who's the one who's screaming the loudest because she's living with it every day. She cleans the floor every day. She's the one who sees the defects right up close.
Yeah, and to further, I guess embrace what you said. There's like they think that the contractor did a bad job, and they believe that a different one would be able to fix it.
Correct.
And you know that that's not the case.
Correct.
They have done a good job.
Yep.
It's not a good situation.
Yeah. Nobody's happy.
Yep.
Yeah. That's why I don't do a lot of residential work because no one's ever happy.
Correct. So there's a couple of pet peeves that I have in residential. One of the biggest ones that I have is protection. And residential slabs being protected. So we've had the conversation. We've got them, the client to come around and go, all right, we're going to do the slab this way. We're going to control as much of the environment as we can. We're going to put the extra steel in to control the cracking. And now they want to protect it during construction.
And now the colour's going to change.
Why would the colour change, Pete?
Because concrete is very sensitive to the rate of moisture loss. So if you cover it, you have variability that occurs in the rate at which moisture leaves the concrete, and it will continue to lose moisture. So the colour of the concrete will vary if you cover it.
Right. But these products are marketed as breathable floor covering.
Yeah, they're not. Now, if you've found one that works, please let me know. But the most common one is to cover it with polythene. And that doesn't work. Gorilla board doesn't work either. And if you've got laps, you will see a colour change on the lap.
Yep.
If you butt it together, you will see the colour change on the line where the butting together was done. If you cover it with Hessian bags or something like that, it'll be different.
Yep.
The success that we've had in the past, where like in a Coles store, was they used scissor lifts to access the ceiling works. And the most success we had there was to use 2 calico painters drop sheets.
Yeah.
And you put one under the scissor lift and you put one in the location the scissor lift is going to drive to, then drive onto that one and pull up the other one and rotate it around to the next spot. And they're only there short term and they do breathe.
Yeah.
And so essentially you're looking for care. But in a house, once the roof is on, you've got the ceiling to go in, and pretty much after that, there's not a lot of stuff that can get dropped to damage it.
You'd be surprised.
Okay. Well, I think part of that is the education of the builder about how he manages his trades and what happens next, particularly if it's a burnish floor that you're just going to polish.
Yeah.
You can't really fix visual defects.
No, that's the one that they're trying to control the most. During the construction, it can't get damaged. It's already the finished product. It's only going to have a very light polish at the end here, so we've got to maintain that. So we're going to be diligent about it and cover it.
So maybe the option then is put hydronic heating in, do a topping slab, put it in after the walls are in, and your guys just have to suffer the hard work on the edges.
Going back to the whole surface polish, the burnt finish inside of a residential project with the walls in place.
It's hard. It's hard. You need edging trowels, and the closest you're going to get to the edge is about 20 millimetres. And maybe that's a location that you have a slightly thicker skirting duct or skirting to try to cover that area. It's a difficult task to do in a residential because you have so many walls.
Yeah.
In a burnish finish in a warehouse is easy because the edges are against the wall. You can't use the space very well against the wall because there's columns internal that block you from access.
Yeah.
So all of the poorer finished concrete is against the wall, and no one sees it.
Yeah.
But in a house, everybody
sees
everything.
Yeah. So to weigh these up here, you've really just got to. Education is going to be the key.
Yeah.
To getting this one over the line because we already talked before, but the best concreters are out doing the big square meters.
Yeah.
And so you go into an environment where we've got a whole lot more variations or variables, and we've got to work around all of these edges, and we need a top-class concrete finisher to get this type of result. But he's probably making big bucks somewhere else today.
Yeah, they're making a lot more money in industrial.
Yeah.
And they've got better equipment.
Yeah.
They have trailing machines they can sit on and ride, and they're doing most of the work with big equipment.
They don't go through a standard 800 door?
No, correct. So back in the residential, they're using a small walk-behind trowel, and your timing is critical to get that finish on it. I think most house slabs will be lucky to get more than 3 or 4 passes with a trailing machine.
Yeah.
Burnish finish needs 10 or 12.
Right.
It's a lot more work. And so you have to finish each part at each pass that you do with the trailing machine. You have to be there at the right time.
Yeah.
And so there's a whole lot of knowledge and experience that comes with trying to do good burnish finishes. Now, I have seen some good residential burnish finishes, but it's not common.
Yeah.
80% of the work is low quality.
Yeah.
It doesn't need to be anything better than that. And I guess the burnish finish you're into is ultra niche. You're probably talking about not even 1% of that marketplace. So who are the guys who can do it? And you can probably guarantee that the builder has taken the cheapest price he can get from the guy who normally does the 80%.
Yeah. Yeah. Oh, yeah. Depending on what sector of the market that we're in, and that's, I guess, goes for everything.
Yeah.
But I would say over the last 5 years, we've gone from having maybe 5% burnish finishes to probably around about the 20,
right?
To possibly, probably about 20%.
Yep.
And of course, with that comes a demand. With that comes the skills.
But that's 20% of your marketplace. That's not 20% of the housing marketplace.
That's what I'm getting at. It's like you've got the demand is created in the skill for it, but then that's such a small portion of the entire industry. So the cost of doing that is still very, very high because the supply is so low.
Yeah. Yep. Yeah. Supply is low.
Yeah.
And it does come back to, it's not really a cost issue. It's who's available.
Yeah.
We've been living with that for years. There's not enough available.
Yeah.
Yeah. And I don't see that changing anytime soon.
Yeah. I can see why they get involved in residential too much.
Yeah.
What you're going to be arguing with.
Yeah. Yeah. It's just everything's difficult about it from where I sit. And Robert and I are an ultra niche business. We just can't afford to get bogged down into other things because we've got other clients screaming at us because they're trying to get on with theirs.
Yeah.
We always react to the fresh concrete projects. The ones that have already gone hard, they can take a lower priority.
Yeah.
It's the fresh concretes where we find our biggest demand to get on and help with things.
Yeah.
But with the residential contractors, if we had somebody listening to doing a better job, there's pretty simple techniques we can teach them about how to do their edges better. We find most visual defects occur along edges or related to edges.
I would agree, yeah.
And if we can improve the edges and get them really good, I do find that visual defects that might exist in the middle are not looked upon so difficult if the edges are good. If the edges are bad, then every defect on the floor gets looked at.
Absolutely.
And I find that in industrial as well. Get the edges right, no one looks in the middle.
Mm-hmm. Okay. So they're going to call you for those for that education. You're running an edges seminar anytime soon, Peter?
I'll be always happy to host an edges seminar. That's the thing I find the most satisfying to teach concreters how to do better edges.
Yeah.
Unfortunately, most concreters have the attitude, I've been doing this for 20 years. What do you know? I've developed some really easy techniques and I do get concreters look at me and say, why didn't I think of this? Because it's so simple.
Yeah.
And so it's easy to make an impact.
I think the power is in their hand to make a whole lot of concrete polishers very happy.
Yeah.
Because concrete polishers know when I'm walking into a house, they said the concrete's good, it's a burnt finish, and I've got to go in there and make it look good.
Yep.
The first thing I'm going to look at is how did they do the edges. That's going to tell me how skilled the concrete finisher was, and it's probably going to dictate everything from here on out.
Correct.
How much time we're going to have to spend on site, so how much cost is going to be associated with it to get a decent result. I mean, they're not walking into projects going, we're going to make a great finish here. They're going in there going, how are we going to get this acceptable?
Okay, so my rule of thumb is if you can see that the edges have been hand trailed, you know they're bad.
Yep.
Straight away.
So how are they getting done then if you're not using hands?
Don't use a hand trail.
Right.
So most concreters use a hand trowel when the concrete is still plastic.
Yep.
And they've pushed the coarse aggregate down. And if they've tipped the edge of their steel trowel so that the edge is in contact with the concrete on a reasonable angle, it will have lots of little chatter marks in it.
Correct.
And the concrete colour will be different. It'll be light.
Yep, seen that.
So I know that edge is bad. And you've got a lot of grinding to do to reduce the depth to get down to the good stuff.
Mm-hmm.
But the colour will be different because it's allowed moisture to leak out at a faster rate than it did on the internal area that had a power trail on it. So my methodology is about screeding to level, using another tool that I call an edging bump cutter to run the edges with that so that you're not hand trailing it, and then getting the trailing machine as close to the edge as possible. So there are edging trowels available that will get within 15 or 20 millimetres the tips of the blades, so you can get very close to the edge. If you've got access to overlap the edge with the trailing machine, that works even better. But that's how we do it, and we don't use hand trowels. So my mantra with the concreters I work with is do not use a hand trowel on the edges. And think about this. A hand trowel is a finishing tool. They use it at the time when the concrete is plastic, therefore you should be using levelling tools. Mm-hmm. So only use levelling tools when the aggregate can be pushed down into the concrete.
Yep.
It's pretty simple, but most guys don't do that.
Mm-hmm.
That's not how they're taught. And they don't think about a different way, because trying a different way might not be successful. And the concrete doesn't wait for you. It's going to set. So if you didn't do it right in the alternative, now you've got a mess.
You got to run with what you do, don't you?
Yeah. So in reality, it's fear that stops them from changing. So when I come along and say, well, do it like this, or I show them do it like this, then it's like, oh, okay, I've given them permission to experiment a little bit, and that there's always a recovery position if they follow my tool.
Yeah.
Then it works out better. So once I've educated a concreter how to do that, as long as his boss doesn't tell him he's an idiot, he'll keep doing it that way.
Yeah.
He'll always get a better outcome. So if some of your guys have got favourite crews that they get to work with, then maybe we can help them upskill what they do.
Yeah, okay.
And get to a better outcome. But yeah, look at the edge. If you can see it's been hand troweled, you know you've got a battle on straight away.
Yeah. Oh, absolutely. It's going to tie you up on that project for a matter of extra days.
Yeah.
Yeah.
Yeah. Okay.
All right. So that was one of my questions to you. Was the burnt finishes, because you do those on large scale, and we're talking about doing it on the micro scale here by comparison. So I think those tips are really helpful. A couple of other things I'd like to know about, because they're hot topics for concrete polishers.
Sure.
Additives. In particular, there's probably the most talk is around about fly ash. We don't get a lot of questions about slag, but I'd like to know the differences between them and why they're in modern day concrete, why we're seeing them.
Okay. So I don't class slag and fly ash as an additive. I class an additive as a chemical.
Okay.
Slag and fly ash are what we call supplementary cementitious materials. So the drive to lower carbon in our world means that concrete's under pressure to use more supplementary cementitious materials, fundamentally because it's reducing the amount of high carbon producing material in that concrete, which happens to be cement. Mm-hmm. So cement uses a lot of energy in order to make it. Slag and fly ash. Slag comes from grinding slag that came out of a blast furnace when you make steel, and fly ash comes from the exhaust from burning coal. And so they capture that so it doesn't go to the environment. And then after there was a big mountain of it, someone realised you had an alternate use and you could mix it into the concrete. So both those materials work different ways. When cement and water react, they make a compound called calcium silicate hydrate, and they release lime as a byproduct. So the lime is essentially in the cement to start with. So in the presence of moisture, lime will react with fly ash to make more calcium silicate hydrate, effectively fill up the little spaces in between, and you get a cement growth. So concrete with supplementaries in it will get an increase in strength beyond 28 days that you wouldn't get from just cement alone.
Right. So
there is some durability benefits from having done that. You can also use slag and fly ash to offset alkali aggregate reaction problems you might have with your aggregates. So some aggregates, when they're in contact with alkali, those start to break down. It's a 20-year journey, but we want our house to last longer than 20 years.
Mm-hmm.
So that's why we would use some supplementaries for that to offset that reaction. Now, slag tends to react on its own in the presence of alkali. And so if we get into really high proportions of slag, then we've taken out some of the alkali content from the concrete by reducing the cement.
Gotcha.
So the future journey will be on really high proportions of slag, is that the concrete producer will probably add an activator, which essentially is a high alkali product, something like caustic soda, but a little more refined. Mm-hmm. So the addition of the alkali will be what makes the slag go. Now, in our chatting, we talked about finishing, what happens on the surface.
Yeah.
So slag and fly ash are lighter materials, so they tend to float to the top. So that layer on the surface that you're trying to get your trowel finish on will probably have a higher concentration of those materials in it. So if it's got a higher concentration of fly ash, then retaining moisture after the concrete's set is a big deal. And so putting a curing compound on it heavily at the right rate is important to retain the moisture. Now, I don't think many house slabs get cured.
No, they don't. At least that's not not intentionally cured.
Yeah. So the old-fashioned way of putting a sand bund around the house and flooding it works really effective.
Yeah.
But it has to be done continuously for 3 days.
Yeah.
Otherwise, it doesn't work properly. So slag, if you're able to increase the alkalinity back into the mix, then the slag will go off and everything's hunky-dory.
Mm.
But what we're seeing is that when you go above 30% replacement, there may be hardness issues at the surface, and there may be durability of the surface because of the high proportions. So we think that going forward, a densifier added immediately that the concrete is finished, or applied as a finishing aid, would be very effective in trying to get that surface hardness back.
Yeah.
That you're missing out on by the high proportions. So the green movement is holding us at the moment. We need to have about 20% replaced. Part of the problem there is the benchmark they've set's got a lot of cement allowed in it, which it's a ridiculous amount of cement. So you don't have to save a lot at the moment. Next year, that might be different. We might be looking at 30%. And then the year after, we might be looking at 40% as being the requirements to get your Green Star ratings. So there's a push to go that way. The concrete companies are pretty happy to do it because the cement companies have all run around and bought the supplies of slag and fly ash and put up the price.
Cool. That's going a bit into our next podcast. Yeah. Well, I just wanted to bring something else up that we talked about last week in regards to the manufactured sands, because for quite some time, the conversations I've been having with contractors that are struggling with the manufactured sands, and this was something that you taught me last week in our conversation. I've always thought that there was an issue with the manufactured sands, that they didn't resist the heat as well, and the edges of them were not necessarily, I guess, that they weren't as good as natural sand. In that, I thought, well, that kind of shape, that's going to come out in the concrete, and when we're seeing issues with sand, manufactured sands in projects, is typically when we're starting to get into the top end of the honing, so like a 100 or 200 hone, or up in the higher end in the resins where we start to polish above 400, we start seeing manufactured sands coming out of the concrete and scratching the floor. And you made a good point in that you said that my theory doesn't make much sense, in that you would expect that the natural sand would have more trouble in this particular area. And so give us a bit more information on the type of sands and materials that I guess what makes them, I guess, in some ways superior in this particular situation, and why I was wrong.
Okay, so natural sand, the particles are generally spherical.
Yep.
They're windblown, or they're like dune sands are windblown, and river sands have been washed, and glacial sands have been pounded when the ice was flowing down. Mm-hmm. So those particles have rolled across each other and they've worn off the sharp edges. Mm-hmm. So that's that you've ended up with. So particularly if the quartz has come out of granite, it's quite sharp and angular. So eventually it wears and you end up with this nice spherical particle. Crusher dust, on the other hand, is wedge-shaped.
Yeah.
And so what you've just described to me, I'm thinking is where that particle is laying fairly flat and you've exposed what is the feathered edge. And the feathered edge, you're right, it would pick up more heat and then it will pop out and cause you the problem. And I guess particularly when you're exposing the aggregates in some form by having taken off that cream layer at the surface, if you think about concrete, normally has the aggregates completely encased by the mortar. But when you grind off the surface, you've reduced a whole lot of the material that holds that aggregate into the matrix. And so now it's only the underside that the glue is on that's holding it down. So it is liable to pop out. And so heating up those feathered edges, or at the same time you've got a shearing force occurring on them by the action of the discs, then it would be natural to see them pop out.
Yeah.
I don't know what the answer is to stop it, but we recommend not to use more than 30% of the sand as crusher dust.
Yeah, okay.
About a third. So 2/3 natural sand, 1/3
yep.
crusher dust. Some of the concrete companies are doing 50-50.
Okay.
And potentially they're the mixes that you're getting more trouble with.
Yeah, okay. Well, I think I think taking that into perspective, I mean, when it comes to the natural sands, they're more of a round shape.
Yeah.
So they're more likely to come out of the concrete when they're under duress, when we're doing that earlier grind because of their shape. But we're probably not seeing the problem later on because that's coming out so early because it comes out easier than the manufactured sands do.
Yes. Well, the natural sand being quartz, it has smooth surfaces.
Yeah.
And when you grind it, once you grind more than half of it off, that
pop straight out.
It'll pop out because it's not being held in.
Hence, it's coming out in our early stage grinds rather than in our polishing.
Yeah. And so the crusher dust, you're right, it's more porous. It's got more surface bonding, even though, and it's had more, I guess, intrusion into the pores of the material with cement. So it's got a little bit more bonding it in. And so effectively what you're doing is you're working harder to get it out.
Hence, we're seeing it in the later stages when it's really under duress, and that's when it actually comes out.
Yeah.
Whereas the natural sand has come out in probably 30 or 50 grit. See you later. Doesn't pop up again later on.
Yes. And if you're not reducing the surface level anymore, then you're not going to keep exposing it.
Correct.
Yep.
Yeah.
Yeah. So I don't know what the solution is other than get the concrete supplier to hold back on the amount of crusher dust they use.
Yeah, I think that's a bit of a hard one.
I think it is.
We're only concrete polishers, man. We've only been doing this for 5 years. They've been doing it for 20 plus. So if we're just talking about who's been around longer, who's going to win the argument?
And it's their concrete. And your customer ordered normal class concrete, so they can give you whatever they want to give you.
That's right.
Should I touch on at the moment the difference between normal class and special class? I think I should.
What are they?
Okay.
Are these the seminars that you run?
No. The concrete is manufactured to a code. and it's AS 1379. And in that code, it classifies concrete in two different classes. You have a normal class with a capital N and special class with a capital S.
Mm-hmm.
Normal class is the vast majority.
Right.
Most engineers are designing their structures based on normal class. Post-tension slabs are special class. They've got different characteristics. Steel fibre reinforced concrete is special class, got a different characteristic.
Yeah.
If you specify a shrinkage strain or a water cement ratio or something like that, then you've got special class. But the vast majority don't do that. And so normal class only has to make the strength and have a shrinkage limit that's actually very fat. So normal class concrete could potentially have a lot more cracking than what a restricted shrinkage limit concrete does.
Mm-hmm.
And basically the concrete supplier is at liberty to put in it whatever they like as long as they make strength.
Yeah, right.
And they test their strength off perfect curing, 28 days underwater at 23 degrees. That level of testing is never achieved in the field. A level of curing is ever achieved in the field.
Right.
But that's the standard by which they get judged upon. And we often see this in new suburban areas where the estate's been developed, all the footpaths and the driveways are put in place, and then we get a phone call from the council to say our brand new footpaths are dusting. We go and have a look. Sure enough, they got 50% replacement, 25% slag, 25% flash. And they weren't cured and they were poured out in the open and they're all bad, right? And so it all goes dusty on the surface. There's good concrete lower down, but the surface is what's wrong.
Correct.
So the concrete suppliers then, unless they're told you have to have this durable surface, they're going to give you the normal class that was on the drawings.
Gotcha.
So if it's a special class concrete, the technical department at the concrete company will get to see the specification before the job's quoted. If it's normal class, just go straight through to the orders office.
Yeah, right. And so I'm assuming there's a cost difference here.
Potentially.
Yeah.
Yep. Yes, most likely there is a cost difference. So our special class is more expensive concrete.
Yeah.
But if you know that if the builder knows he's building a burnish finish slab in a house, he should be seeking a special class. And they often will only do it with 32 MPa. It's much harder to get a burnish finish on a 32 than it is on a 40. And all of the work we do industrial is all 40.
Of course, yeah.
Bunnings use 40 because they have very high proportions of pedestrian traffic, and pedestrian traffic is very hard wearing on surfaces.
Whoever would have thought.
Yeah, much more than forklifts. Forklifts actually, by comparison, are quite kind. And if you want to see evidence of that, go into a brand new Bunnings store and come back six months later and have a look in the first traffic aisle and see what the gloss level is different. Or go into any Bunnings and look in the first main traffic aisle and then walk to the back wall and have a look in the traffic aisle on the back wall. It'll still be shiny. The one on the front will be dull.
It's a sick obsession that you have with concrete, Peter.
I know. I could tell you stories. I tend to infect people around me with my concrete obsession, but 40 MPa is what you would need. Now, in a house, you could get away with 32, but it's harder to get the burnish on a 32 than it is on a 40, simply because the amount of cement that you've got in that surface layer you're trying to get the finish on.
Mm-hmm.
And so 40 MPa gives you more cement.
Yeah, right. Okay, well, then that's going to lead into the question I'm going to ask you next. Open checkbook, building your own.
My wife doesn't like concrete floors.
All right, so we're talking about a multi-level home. Where
For me,
she lives upstairs, you live downstairs. Vice versa.
Okay, so in my man cave,
in your man cave, yep,
and my garage, I would put a hydronic heating system down on the topping slab.
Yeah, okay.
And I would do exposed aggregate finish.
Exposed aggregate.
Yeah.
Is that for aesthetics?
Yeah, and I'm exposed and fully exposed and polished. That's what I would do.
Yeah, all right.
I like the appearance of that. I also like walking on that. It's soft. It feels soft under your feet.
Yeah.
In my garage, I actually did a dry shake, and my wife thinks I'm mad, but when I walk on it in bare feet, it feels soft.
That's good, isn't it?
Yeah. So that's what I would do. Yeah. And I would probably call my mates up and get them to come and pour the slab with me. I wouldn't trust a concrete.
Very good.
And that's what I did in my garage.
Oh, really?
Yeah, I used a laser screed and got my mates to come and we all chipped in and did it.
That's fantastic.
Because I didn't trust the concreter that did the work. And that concreter builds hundreds of house slabs a year.
Yep.
I didn't trust him to do it. Yeah.
Do it myself with a few mates.
The builder couldn't believe it.
But like you said before, the engineer actually put in a whole lot more steel. So it's not cracking today
it's
either.
It's not cracking. No, we've got a good finish and it's easy to clean and it wears really well. But I would like exposed aggregate polished finish in my house.
Mm-hmm.
Yeah. And I would be really, really critical of all of the defects that are in there. But I know it's possible to not have visual defects in these slabs if you spread them with really simple rules.
Mm-hmm. Okay.
As much as I like burnish finishes, I know I'm not going to get the quality in the house.
Playing it safe, it sounds like it. So if all contractors that are listening, if you see a specification come across the board or a quote come across your desk, it's got Peter's name on it from Concrete Methods. Steer clear away from doing that one, right? Worst customer for polished concrete. It's going to pick you to bits.
Yeah. Oh, well, but anyway, my wife will never go into the man cave because she won't like the floor, so you don't have to worry about her.
I have no idea how you guys ended up together. Is it the opposites attract thing? Must have been.
No idea. I truly don't know.
Well, Peter, thank you so much for joining us today. There's so much more we could continue to talk about. You got an amazing amount of experience. Really appreciate the sharing some of that with us today. If I could just, learn as much of what you've forgotten, I know I'd be a long way ahead of where I am now. People can call you if they need your help.
Yep.
And where would they find you?
They need to find my phone number, and I don't have a website or social media.
There you go.
So they probably need to find me through your company.
So if you want to get hold of Peter, and he's using me as the gatekeeper here because I know exactly what type of clientele he's trying to avoid, give us a call here at Works Plus, and we'll pass on on his details if you qualify.
Thank you. Thanks for having me, George.
Have a great one. Thanks, Peter.
See you later.
This show is proudly supported by Works Plus. Works Plus brings total solutions to all concrete grinding and polishing contractors to make it totally work for them in their operations. We hope you've enjoyed this episode. Make sure to tune in each week where we're going to dive deep into all things related to concrete grinding and polishing. We're here to help you so that you can boost your outcomes on the floor.